Another way of getting your information is via serial communication. So we're going to have a look at the basic concepts of the definition in a protocol on how to get information via serial communication. Serial communication is about a command, a request structure, and a specific response. So you will see that popping up into the definition as well. You will see a command with a specific format, and I have my response, specific format. So I'm sending out something and I expect to receive this. And I'm going to match this with my incoming information. Is what I received the same as I expected? Yes, no, and then I can do something with it. Now let's have a look in Data Miner Integration Studio and see how that basic concept looks like. So I here have a protocol, basic definition of a protocol. I have my timers again. On a regular time, I would like to get something. So let's jump to the timers. I have time every 10 seconds, and for instance, every 1 minute I'm going to do something. I'm going to retrieve information. So what am I going to do here? I have group 2. Let's quickly jump to group 2. Remember, groups are my to-do list. I would like to get information. Now this is a serial communication we're dealing with. So I have a combination. I have a pair. It's a combo, command, response. So let's look at this pair. In this case, my to-do list only has one pair. In my pair, I have a command and a response. Now, imagine that I have command, I expect this case, but I could also expect another format. In this case, I could have multiple responses. So let's just copy paste this one so you can actually see it. Imagine that we would have, let's use number 1 as an indication. Now, this example, it doesn't make sense because it says device state. But it's just to show you that this is possible. I can add as many as responses in here because it will try to match with that component. So I have my command, I'm going to send out something, what's your name? And I expect it to be somebody I know, but it could be somebody I don't know. And that opens the room to do 2 different things. I will ask some questions to the person I know, or I will get to know the person I don't know. So I will ask different questions. So I can start different flows based on the responses I retrieve. Now let's return this as it was. Keep it simple. I have a pair, a combination of command and response, and you can see even that we have a other pair here, pair 1 with a command and response. Now let's use this second one to continue. So I have my command. What's in my command? You can see it's jumping. I have here different params. What are my params? It will represent the characters, for instance, that will compose my command as it was described in the documentation. In this case, you can see it in the comments here a little bit. I have a header, it's my start of message. I have some fixed indication, in this case it's called temp, and a trailer, my end of my message. Now let's just quickly jump to these 3 params. So I have a start of something. This is the start of my message, so I'm going to call it my header. The end of something, I'm going to call it a trailer. So I have a beginning and an end, and I don't care about all the other stuff. My command, I can use headers and trailers. In my response, which will be more useful, I can have a beginning and an end as well. Imagine I'm receiving a lot of clutter next to the info I really want. I will tell you, you should start reading from this point and end here. The easiest way to remember this is when I would ask you to read a gigantic book. Instead of just reading it entirely, I'm going to tell you, please start reading from this page until this page. And you're just going to read these pages or these sentences. So I'm giving you a header and a trailer, command, response. Now my header is a fixed component. I want you to start reading from page number 20. So I'm going to indicate where to start reading, what's the header. In this case, it's my fixed value value 1. So it's not a writable character, so it's not part of my keyboard, it's the internal value 1, so I'm going to represent it as a hex value, and that's why you can see the 0x01, it's my hex value 1. Of course, my length is just 1, it's just one value, or the number 1, it's just one length, and I'm going to represent it as a string. It's fixed length because I'm indicating what the value will be. Trailer, very similar structure. It has a value 2, it's a different value, start from this and here. Let's go back to my command. I have a different part in there as well. I had a fixed temp command. So this is going to retrieve, for instance, my temperature, and the command to get it is temp. You can see I have 4 characters here, so the length is 4. Now in DIS you have this little help indication in the comments, so it's already indicating what the length is of my value. If I, for instance, would add another value in here, you can see that it's returning to 6. It makes it easy for you to correct yourself in case you have a large hex value that you would like to add in here. It's not really readable, the hex values, but it will make sure that you see what the final length should be. Now, what's the difference here between the header and the trailer I had? The type is called fixed. Now, what happens often is that we confuse the type fixed with the length type fixed. Remember, my header also had a fixed length type because we are filling in the value already. I'm going to give that this is the room, even for responses. This is how many bytes I expect, or this is how many characters I expect to receive. Still, it could be that it's a header. I expect X amount of data there, or that the type is read. So the type is completely different from my length type. Although it's both fixed, don't confuse yourself when we talk about a fixed param. This is the type fixed param, so we're going to indicate what the value is, or we're going to limit that this is the amount of space you have to fill in something. Param, unique ID, a name, description, type fixed, and an internal indication. How should data miner deal with this? The combination of my header, my fixed component, and my trailer, this is my command. Now let's look at the response. And my response contains out of several components. Now remember that the response is this is what I expect. So it might be that I'm receiving something completely different, and you can see that we will have timeout. It will retry. This is not what I expected. Let's send out the command again. Still not what I expected, so the amount of retries will be used. In the end, it's still not what I expected, and then I will have a timeout. So it could be that you still receive information, but for instance, you did a firmware update on your data source and the format has changed. So it's not really an issue, it's simply the format of the data source has changed, and that's why you don't see the values on your screen anymore. I will show you how to look at these things and detect them in a short bit. Let's first have a look at the response definition. So again, I have a unique ID, I have a name, I have a description, and in my content, I have a set of params. This is how it should look like. So very similar to my command. Let's have a look what we have. We have here a header. We've seen a header in command already. It's very similar. And then I have my temperature outdoor. Now, what's my temperature outdoor? It's a value I don't know yet. So I don't know what it will be. It could be 1, it could be 20, it could be 100. Who knows what the temperature is? Although outdoor temperature 100 would be quite hot, but still it could be that this needs a calculation. And that's what we have here. It will send between a value, minimum value, maximum value, and I will need to divide it into 10 so I can see my decimals as well. For instance, it could be sending me the value 200, and I'm going to divide it by 10. Makes more sense then. We have 20 degrees. Now what we have here is a formatted param, so it can be displayed. So I have a lot of information here. I can make sure I can trend it. So I have my little trend graph next to it. I have a pop-up in my information. I'm going to indicate that this is a read component. It's not a fixed, it's a read component. I'm going to read out the value I will receive. Internally, it should be used as a number. As mentioned, I'm going to add a bit of a calculation on this, and I'm going to display it. I'm going to display it, make sure it's available. So that's the RT display true. It's available outside of my protocol, so it's available in my cube. I'm going to really look at it as a human being, but it could also be available for other components in DataMiner. Automation can use this as well. I'm going to give it a nice position so I can open up a page and really see it somewhere, and it's all part of my display. So let's collapse this. And I'm going to make sure I have some default alarming there. Now, adding alarming, monitoring true, and trending true doesn't mean it will already start alarming and trending. So it's not because I'm adding alarm monitor true, I will all of a sudden have pop-ups of alarms. What this does is makes it available in an alarm template. So I still need to apply an alarm template on my element to get either trending for a trend template or alarming alarm template. What we do with these values is make sure that we have some default values. So whenever I open up my alarm template, I will see some values there. I can just enable the component I want, the param I want to alarm, apply it on my element, and there you have it. I have some default alarming in there. So having this data here in my definition will make it easier for the person configuring things. And that's what we want to achieve. We want to make things easy via our development. Now the measurement is how am I going to display it. So this is a number and I'm going to use an analog view. It's not just going to represent the number, but it's going to give a nice analog thing. You can see that's going up and down in my temperature. So this is a bit of fine tuning. But you could see there's nothing extra in here to indicate this is the info. It doesn't have a length. This is the amount of bytes you need to receive because I don't know how long it will be. So you could see that this is actually the length next param. What does this mean? You might have seen this before. It didn't really make sense to see next param. Next param means I'm going to read it out until I reach to my next param. In my response, it will have a next param. If there isn't another param next to it, it will read until the timeout time. As long as I can, maybe I need to read that book during my business hours, or when my business hours end, that's the moment I will stop. So I have a timeout time. So next param. Let's have a look at the response. I'm mentioning next param. So I had this 1101 param, my temperature outdoor, and then the other param is 20. This means this needs to be a fixed. If it would be another next param, it doesn't know where to stop. We need to define this as a param. Now in this format of my response, I have a start, I have a value, and then a separator. So I could read you start from this beginning, read a value until you reach this character, and then you can start reading another value until you reach the character, and so on. So you can see I have a fixed separator between the values I need to read, and at the end I have my trailer again. Now what's my fixed separator? It's very similar to what we've seen already. Type fixed, I'll give it a fixed length and value. Quite easy. In a way, we have responses. We will define it with the variables that we have. This is the structure I expect. Command, this is what I'm going to send out, and my commands and responses will be part of a pair. For this command, I expect this response, maybe more responses, and I'm going to add this in a group so I can start executing them. I would like to retrieve the information from for my device state, for instance, or my temperatures. I could add multiple pairs into one group. Remember, the more in your to-do list, the longer you're going to block things. You will be busy with something, so you can't cancel it. So be careful with this, but it's possible. And of course, we had our timers. Now you can see that we still have some other components in here. Why would I have these things? I'm going to make my commands at some point. I need to make sure I compose it, and this is the data I'm going to send out. Currently, what I've done is define it. It should look like this. But at runtime, I need to compose it together and really get it sent out. And that's why we have this trigger. So before I would like to use this command, I'm going to compose it, I'm going to make it. So I'm going to grab the values of all the variables, all the params that I have, put them together, and this is my command. It's like reading a piece of text and then reading them out loud. This is the command I'm going to send to you. ID each means before, in this case, before every command, so each command that I'm going to use. So whenever I have a group, I'm going to execute my pair, there's a command in there, that's part of that each as well. So for every command, I'm going to make command. Now what's the make command? Quite simple, make command. How does it know what command to make? There's no ID indicated, it's not indicating, for instance, let's add ID number 1. If I would do this, it's only going to make the command state of my device. When I would leave this out, it's going to use the ID that was used in the trigger. It's only going to use this when the on components are the same. So in this case, it's each command. So whenever it's command 1, the each, you could represent it as then 1, command 1, it's going to run the action. The action will do what? Well, for that command number 1, it will make it. In case it would be command number 2, the 2 is replaced. The each is replaced with 2, which command, before command, action, command 2 will be made. So the each and the action will make sure they are linked together. Now that's a command I'm going to send out. I'm going to compose or take the all the variables I have, compose them together, send them out. For the response, quite similar. I'm going to read out the information. I'm going to grab the incoming information and I'm going to match them with the expected response that I have. So I need to read it out and match it, make sure it's filled in into those variables. So when I look at my response again, I need to check if the value of this start message, the separators and so on, if this matches with my incoming data. So it's trying to match with my structure and fill it in at the same time. So it could be that, for instance, my temperature outdoor is filled in because my header is perfect and my separator is there as well. But then I have some completely different rubbish in my incoming information. So it's not matching the last part of my response. It did match the first, so my temperature outdoor is filled in, it's shown already on display, and the others are kept empty or with an old value or with a completely incorrect value. So that's the danger. I could make a internal response and see if it's fully matching, then I will copy it to my displayed information. But keep this in mind, it's going to read out the information, populate my response. Now, when would this happen where it doesn't match? Again, it's a firmware update. So something really needs to change before it's no longer matching. So in normal run, we will have our start, we will have a value with a separator, so I can fill it in. I will have another value until the separator, fill it in. And in this case, another value until my end character. So it will fill in my response due to the action read. Let's go over them again. I have a trigger. before each command, before I'm going to send it out, I'm going to grab all the variables, make a command out of it, and I can send it out. For the response, whenever I'm receiving a response, so before I'm going to do something with the response defined, I'm going to read out the incoming information, make sure it's filled in. That's the basic structure of a serial communication. Next, we're going to have a look at HTTP.